2.4 Example 3. Before we actually get into solving Example 3, I first want to talk about the definition of a tangent line. A tangent line is a line that intersects a curve at exactly one point. This means it's going to touch the graph at just one point and then never touch it again. The difference between a secant line and a tangent line is a secant line goes through 2 points on a graph. The slope of a tangent line is the instantaneous rate of change at a point. So that when you determine the equation of a tangent line and you find the slope, that's going to give you how fast that function is changing at that second in time. So let's take a minute and look at a graph to understand really what's going on. So if we look at this graph, we have the graph of y equals x squared, and we have a secant line that runs through it. So as I move the point A and B both move to create a secant line. But as I change h, which is the distance between the points, you see that as h approaches 0, the line becomes tangent. So when h is large, you have a secant line, and as you let h approach 0, the line becomes tangent. So the closer h is to 0, the better approximation you have for the tangent line. So in this example, we're going to find the slope of the parabola y equals x squared at the point 2, 4, and then we're going to write the equation of the tangent line at this point. A good side note to make is that a tangent line is just a secant line as the 2 points on the secant line become infinitely close. This is what we saw with the graph a second ago. So in general, if the first point is x, then the second point is just x plus h, and then we're going to let h approach 0. So step 1 is we're going to use the definition of instantaneous speed with the function. So we have that our function is y is equal to x squared. And the definition of instantaneous speed is the limit as h approaches 0 of f of x plus h minus f of x all divided by h. So now what we're going to do is we're going to actually work out the function. So we get that this becomes the limit as h approaches 0. And then our function is x squared, so you get x plus h squared minus x squared all divided by h. And we get the limit as h approaches 0 of x squared plus 2xh plus h squared minus x squared all divided by h. Our x squareds are going to cancel. And we get the limit as h approaches 0 of 2xh plus h squared all divided by h. So this becomes the limit as h approaches 0. I'm going to factor out the h, and I get 2x plus h divided by h. These h's are going to reduce off. And so this becomes then the limit as h approaches 0 of 2x plus h. The 0 at this point is going to go for h. And you get this is equal to 2x. So we can actually use this equation that we got, 2x, to find the slope of the tangent line of any x for y equals x squared. So step 2 is to use the x value to find slope. And so our point that we're looking at is 2, 4. And so we're going to use the x value from this, which is 2. So we want x equals 2. So we have the equation for slope is equal to 2x, which is going to be 2 times 2, which is 4. So this means that the slope of the tangent line at x equals 2 is 4. The next step is to create the equation of the line. So I have the point 2, 4, and I have the slope, which is 4. So now we're just going to use our equations of lines, and we get y minus y1 is equal to m times x minus x1. So we get y minus 4 is equal to 4 x minus 2. y minus 4 is equal to 4x minus 8. So y is equal to 4x minus 4. Now I am going to make the point to say that either of these equations is okay. On an AP test on an FRQ, I recommend you stop here because it's a less chance to make a mistake. However, on a multiple choice question, they might put either one of them. So on your own now, I want you to use the function f of x equals x minus 1. And I want you to determine the equation of the tangent line at x equals 2. So take a minute, use the steps we just did in order to find that equation. Alright, let's take a look at it. Here we go. So now that I've gotten to that point, I've determined the equation to find the slope of the tangent line at any point for the graph 1 divided by x minus 1. So now for step 2, all I have to do is plug in the x value. So at x equals 2, and I have my equation for slope is negative 1 over x minus 1 squared. So this becomes negative 1 over 2 minus 1 squared, which is going to be negative 1 over 1 squared, which is just negative 1. So this negative 1 represents m at x equals 2. And the very last step is to write the equation of the line. So we're going to use our point slope form. So here we have this, that the slope is equal to negative 1, and our point is 2, 1. So now all we have to do is plug everything in. And so that gives us the equation of the tangent line at x equals 2 for the graph 1 divided by x minus 1.